Alright, this video is on multiplying two exponential expressions that have the same base, also known as, say, the product rule for exponents. But before we get to that, let's recall 2 to the first power. That really just means, 2, right? But if you had something, say, like 2 to the third power, also known as 2 cubed, that means to write as 2 times 2 times 2, which is 2 times 2 is 4, 4 times 2 is 8. So 2 to the third is a fancy way of writing the number 8. Okay, but this little exponent here kind of tells you what you're doing with the bases. All right, you're probably all familiar with that. But now I want to emphasize the difference between that and that. All right, so this first example right up here, this says the base for this exponent 2, the base is this entire thing of -3 because we have these parentheses around it. Whereas down here on the bottom one, the base for the exponent 2 is just the number 3. The base for an exponent is the number that's immediately to the left of it, and this minus sign down here does not indicate this is a -3 like it does up here. The parentheses here show that we've got -3 as the base raised to the second power. Down here, this just means the opposite. That's what the minus sign out in front means. The opposite of 3 squared. That's a big difference between the two examples. So let's do this top one here. So this first one says the -3 to the second power, because -3 is the base. That really means -3 times -3, and we all know that to mean +9. Right? But this bottom one down here says that, well, the base for the exponent 2 here is just the number 3. So the 3 is what's being multiplied together twice, and this negative sign is just out in front. And so all of that gives us a -9. Because remember, this means the opposite of 3 squared, and 3 squared is 9. The opposite of 9 is, well, -9. Right? So there's a big difference if you have parentheses or if you don't have parentheses, and this really only matters when your exponent is even. All right, so 2, 4, 6. If your exponent's like that, then it matters what the base is in terms of having parentheses around it or not. So just be careful of that notation. All right, so now let's go backwards. So let's see, we've got -7a times -7a times -7a times -7a. Well, another way we could rewrite that, -7a, and how many times was it being multiplied together? 4. So -7a all raised to the 4th power. Note, it is very important that you have the parentheses around the -7a, because that's what's being multiplied 4 times together, right? If you do not have the parentheses, then it looks like this. Right? If you do not put the parentheses in, then it looks like this. And that 4 is only on the a. It's not even on the 7. Because remember, the base for the exponent is the number that's immediately to its left. And so that would be this situation right here, the a. So very important to remember when you have parentheses and when you do not have parentheses, right? Okay, this down here just means -7 times a times a times a times a. And that's not what we have up here. Right? Okay, enough on that. All right, this leads us to this following example. So you have x cubed times x squared. Well, x cubed means x times x times x, right? And then times. And then x squared means x times x. Everybody agrees with that, right? And then we say, all right, well, how many x's are we multiplying up? Well, you got 1, 2, 3, 4, 5. So to rewrite this expression down here in black, you just rewrite that as x to the 5th. Right? That's what that means. That's what the previous example was all about. And so what's the relationship between what we have up here in blue and down here in this last line? Well, the bases are the same, right? Base x, and we keep the base, and we add the exponents. 3 plus 2 gives us the 5. And that is actually the entire product rule for exponents. Right? We're going to write it up as a note. Here you go. To multiply exponential expressions that have the same base, keep the base and add the exponents. Right? That's it. Thus, b to the m times b to the n, m and n are just numbers, that equals b to the m plus n. You keep the base the same and just add up the exponents that are on these two expressions. right? That's the entire concept. All right, so let's look at some examples. All right, example 1, y times y squared times y to the 5th. All right, well, we're multiplying up three things that have the same base. The exponent on this y is 5, the exponent on this y is 2. And what's the exponent on this first one up here? Right, even though we don't write it, it's understood to be a 1 up there. Don't forget, it's understood to be a 1 up there. So y times y squared times y to the 5th, you keep the base the same and add up the exponents. 1 plus 2 plus 5 gives you 8. So y to the 8th. All right? Second example. All right, here we're multiplying negative 3 to the 4th times negative 3 to the 7th. So the base this time is negative 3. So you need parentheses around all that negative 3. And then 4 plus 7 gives you 11. Right? All right, what about the third one? All right, 5x squared y to the 5th times negative 3x to the 4th y to the 9th. All right, well, let's see. We know we can all this is multiplication right here, right? So we know we can multiply the 5 and the negative 3 together to get negative 15. That's going to happen. And then you have x squared, which you can multiply times the x to the 4th here, because remember, all this is multiplication, so we're just moving things around. So x squared times x to the 4th, base the same, add the exponents, you get x to the 6th. And then y to the 5th and y to the 9th, because you're multiplying those together, give you y to the 14th. Right, so this whole expression goes to negative 15 x to the 6th y to the 14th. All right. And then, all right, now I've changed it up a little bit. So the bases don't just have to be, these one-term things here that I have in the previous examples. Down here, x minus 2 is the entire base for this 5 because we have these parentheses around the x minus 2. Right? So x minus 2 here is the base for the 6. So we're multiplying these two things together, and we see that x minus 2 is the base for both of them. So we keep the base the same, x minus 2, and then add up the exponents. So 5 plus 6 is 11. All right, so this goes to x minus 2 raised to the 11th power. That makes sense? So it doesn't matter what your base, if your base is 1 term, 2 terms, 19 terms, whatever, none of that matters. Right? All that matters is that the things that you're multiplying together have the same base. And then you keep the base and just add up the exponents. All right, let's do one more. All right, so 5 to the 2n times 5 to the 8n. All right, so the base this time is 5. And we look at our exponents, and we have 2n plus 8n. And remember that 2n plus 8n are like terms, so we can add them up and get, because they both have the n's there. So 2n plus 8n is 10n. So this 5 to the 2n times 5 to the 8n all goes to 5 to the 10n. All right, does that make sense? All right, that's the idea of multiplying exponential expressions that have the same base. Now you should go practice. Study well. Please let me know if you have any questions.